So now we'll try to define the Gibbs definition for the Gibbs free energy. Okay. So we know G equals to U minus Ts plus PV, and U is the internal energy, which you can say that it is the energy required to create a system. Okay. And Ts, you know, is the bound energy which is unavailable for useful work. Okay. That is, we cannot convert Ts, this amount of energy of the system, to useful work. We cannot convert this amount of energy to work. And what is PV? PV, you can say that it is the energy required to make room for the system. So U is the energy required to create the system, and PV is the energy required, which is the product of the pressure and volume, is the energy required to make room for the system, that is, give the space for the system. And Ts, this product of the temperature and entropy of the system, gives the bound or latent energy which is unavailable for work. We cannot convert Ts amount of energy to useful work. We cannot rest of the energy of a system to use work, but we cannot convert this Ts amount of energy. Okay. So now if we write G as U plus PV minus Ts, then U plus PV, this gives us the sum of this energy required to create a system plus energy required to make room for the system. Okay, so this U plus PV gives the total energy or heat content, a measure of total energy or heat content of the system. Then we subtract the bound energy which is unavailable for work from this total heat content of the system. Okay, so the rest of the energy we get gives us the free energy which is available for work for a system which is at constant pressure and constant temperature, because you know this, we define G for the isothermal and isobaric process, that is, the system has to be at constant pressure and constant temperature. Okay, so now we'll give the definition of this Gibbs free energy. So remember that so if we subtract this bound energy which is unavailable for work from the total heat content of the system, the rest of the energy is a measure of G and which is available for useful work. Okay, so and that will be the maximum amount of energy that can be converted to maximum amount of work. So thus we can define Gibbs free energy in the following way. So in thermodynamics, Gibbs free energy is a thermodynamic potential, and we have already said why it is a thermodynamic potential, because any thermodynamic system, when it is trying to be in a stable state, any thermodynamic system which is at constant temperature and constant pressure, when it is trying to be in a stable state of thermodynamic equilibrium, it will always try to be in the state of minimum Gibbs free energy. So that's why it is called a thermodynamic potential. Okay. So in thermodynamics, Gibbs free energy is a thermodynamic potential that gives a measure of maximum reversible work obtainable from a system. So maximum reversible, why? Because we know only if the process is reversible we will get the maximum amount of work. Okay. Because maximum amount of work can be obtained for a reversible process. Okay, not for an irreversible process. So it gives a measure of maximum reversible work obtainable from a system at constant temperature and constant temperature and constant pressure. That is, any process which occurs in the system has to be isothermal and isobaric. That's why constant temperature and constant pressure. So in thermodynamics, Gibbs free energy is a thermodynamic potential that gives a measure of maximum reversible work. Okay, so if we subtract the bound energy unavailable for work from the total energy or heat content of the system, we get the rest of the free energy for a system which is at constant temperature and constant pressure. Thus, the Gibbs free energy can be used to calculate the maximum reversible work that can be performed by a system from a which is at constant temperature and constant pressure. Okay. Now the Gibbs free energy, just like Helmholtz free energy, is an extensive property that it depends on the mass or the number of particles which is present in a system. And again says G is U minus Ts plus PV, and U, Ts, PV, all these are state functions Hence Gibbs free energy is also a state function, and hence this delta G, total differential delta G, is an exact differential, because for any state function its differential will be an exact differential. Thus delta G is an exact differential.